will continue, and based on the previous exploits, we'll talk about a dry subject in the first presentation.
And if we have some time left at the end, since I'm the last one, I will ask you to stay a bit longer because at the very end I'll give you 2 short demos. That's it.
Tolmácsok, ready? Okay.
What are Exepackers? The simplest definition possible is programs that encrypt or pack other programs and still keep them in a runnable state on the given operating system. So they work in a kind of transparent way. Only the structure of the programs they run retaining all functionality. Where do they come from? I started to deal with computer technique 15 years ago. There were cruncher programs. At that time, we didn't have too many legal products in the country, so we actually copied cassettes from cassettes, and there was a blinking logo. That was the Commodore 64 Cruncher, and then there was a kind of legacy for the next period. They were the popular products of the age. I used an Atari, so actually I was let out of the Commodore craze when the first hackers and packers were much more sophisticated, but whatever they stole used for making music. And then we used, that was in the early 80s when you have the PCs, the Ashcom, Exepack, IBM PCs, and then that didn't work for installing Windows, and if there were packer programs or zip programs, then there had to be programs that either automatically, semi-automatically or manually could pack and unpack programs and cones and streams and whatever. Unpackex was under DOS, and ZUP, Z-U-P, which had a good engine. And now we are in the Windows era. The first PA crypt were kind of fledgling trials 6 to 8 years ago. There were only 2 or 3, and then an avalanche started, and then such as Armadillo, ASPAC, FSG, UPX. IrfanView as a surface application, BS Player as a VDA player, and uTorrent client with third-party applications. Most of the people don't know about them. They work in the same way, only the size is smaller, but later on I will speak about the importance of size. And they are used for their secondary purpose, and not for program protection. And then so heaps of malware, they form a part of commercial copy protections. They use the same kind of technologies for firewalls protections to hide the code, to make it unmodifiable against any kind of hacker, cracker or whatever. And then there is an additional category, non-welcome applications such as cracks and keygens. It will be explained later. It is problematic because from an antivirus point, they are malicious programs, but their operation in itself is not malicious. So we cannot label them as malicious because they won't upset the computer, because they use the same kind of packers that are normally used. There is an Exepacker collection of which we must know that it is not a virus buster collection, but it was born with the cooperation of many antivirus firms. As a cooperation, researcher, developer, lab people share these kind of things. There is a common source, they upload it. I usually organize this common source and the categorization. And what we can say that we have cryptors, and most of it is made up by 41% is made up by cryptors, and different pack types. These are the current ratios. Cryptors, compressors, protectors, installers. Cryptors are cryptors which do not pack. Compressors pack, of course, but otherwise they don't do anything else. And protectors do both, kind of amalgamate both harmful and positive properties of the first two. Installers are nothing but they appeared with the Linux installers. They use similar technology, and we must deal with their processing, because they use malware. Either a part is malware or it is within a smaller package. This is the white to black harmful level of harmfulness. Pure white are the commercial protections. The primary problem with this is that these, in most of the cases, on runnable platforms, pure, clean copies protected from cracking, from being modified. But as far as technology is concerned, these protectors are the top, and they therefore represent most of the program. They stop us to emulate through them and so on. The medium category are questionable grays. So either on malware or pure file appear. It is always questionable for an antivirus company. Freeware program manufacturers use them. Freeware packers. Whoever writes an application makes it free, doesn't want to spend money on any other hiding for his own code. And then we have the black as night, as the night. It's a very rewarding category because 99% of it is malware. We can process them and we don't have to think about them too much. This is what they look like. Structures, capabilities, internals. It started from compression from limited memory. Because of the limited memory, compression was the primary task to save space on Winchester. Nowadays, with the huge several gigabyte, terabyte Winchester, it is of no use anymore. It doesn't matter if an exe is 5 megabyte or several 5 megabytes. That comes from the old thinking. Encryption developed in the meantime, and those who know Windows exe, import and export tables are quite obvious. They would like to hide them, and there are the anti-debugger, anti-virtual machine tricks. and so they protect the program from any kind of debugger, and they wouldn't like to have any stealing from any virtual machine. They can be adjusted, set, replaced, but hardware manufacturers would like to make sure that if a malware starts, then it should be a real active machine, because if it's a virtual machine, then it's very difficult to catch and block. Code replacement from a couple of bytes to long spaces to long strings, and now we get to the point of the top technology of today, on custom virtual machines. Again, it is a wide circle, Cisco-based embedded packers. Within CISC there is a RISC, and more or less there is a native instruction in the original code. They magnify into 4,000 or several tens of thousands instructions. And so many force instructions will be executed during the execution of the original single instruction. If I use it cleverly, then it's a very good trick and a very fortunate idea. It won't load the whole computer. They put it on a small code section on which they have their technology or commercial products, and it is called once during the time of initialization. It runs once, and the rest is in native code. It doesn't slow down and doesn't load the processor additionally. Now, some obscure programming languages reappeared. They are problematic from the point of processing. A shell basic program wouldn't pose any problem. Anybody could write a couple of encrypted packing lines with an X throwing out part. There are the P-code option, which makes it problematic for Visual Basic, which is not using native Windows 32 code, but the so-called black code, which is its own language, and it's much more difficult to get hold of it with assembler, to process it with an assembler, and if somebody wants to load it into an emulator, it's again very problematic. With time, people understood that less can be more. A simpler language can be much more. It's much simpler to analyze than such a P-code. Here I must make an additional remark: how we destroy the myth, and how it can be regarded as mythical that present defense causes any kind of run problems or any injuries to the computer. There are two stories. You've heard about rootkit scandal. Because of the rootkit component, it was widely echoed in the media. Sony came out of it harmed. And it was shown that even big firms turn to devices that are unethical. And the other one is the story of Starforce. That's a Russian company. Many people says that technology implemented by Starforce may destroy the writer, CD, DVD writer. Nobody could really prove it. Nobody could really prove it if any machine was destroyed, but whatever Starforce used as technology were grabbed into the infrastructures of the operating systems, and they went beyond the limits of ethical behavior. how we can rewrite and modify a function within an operating system to use the RAM modules. But in a basic situation, we might state whatever is written well won't cause any harm in anybody's machine. If you would like to avoid the operation of packers and drivers, you have unfounded fears. How can we identify and process them? There is an exa, and we should be able to decide if it's packed or not. And then at the end, within the demo, I will show you with Hex Editor, as anybody can really jump at it. Even the characteristic there will reveal certain things. Strings will show strings. Even these strings could be a break type of information which doesn't say anything. Anybody can push down the brake pedal. What is characteristic here is entropy calculations for packing. Due to packing, the entropy of these programs will grow, and there will be an additional layer above the native layer. And those who saw these kind of things have a certain experience to judge it from visual appearance.
Megoldások erre.
Automated solutions were put in place. Simple sequences were used for detection, PEID and RDG protection ID. These are the better known programs with a simple GUI, and also a large sequence-based database, which on the basis of the sequence will try to identify whether we're encountering known objects or not. Those who have an antivirus scanner log, this is often swallowed, but in the command line several pieces of information can be obtained, and useful information can be gained from this about hackers. And what can we do about this? First of all, we can process it in a native way, so we fully analyze the given packer. We understand the encryption mechanism and the compression. Of course, the decompression and decryption can be written and run in a native environment up to a certain point due to complexities and the energy invested, so that we can keep track of releases and update it. As you saw, looking at the numbers, we're talking about 1,000 versions and packers, and it's quite a lot of man-hours to produce all that in writing. And V32 emulation could be the other solution used to go through the outer layer. Antivirus companies to this very date like this quite a lot. We try to create a V32 environment and run the code that is inserted on top of the program. We try to identify the end of the add-on code, and when it gets back to the original application, and then the code can be analyzed. There are hybrid solutions as well, merging the previous two so that emulation isn't too slow. I'll give you an example. In the case of virtual machines, if 1 byte is magnified to 10,000 bytes, or even a lot more, this could enhance the number of embed instructions, and there are all kinds of tricks that malware producers use, executing cycles, apparently reading and writing from and to the memory, but doing nothing really. And the antivirus engine's emulation is pushed to the very extreme. And emulation includes a certain limit as to the number of instructions it wants to reach. And it's not only emulation that is slow and we want to speed up. There are techniques that recognize the generally used and typical AP-lib and Z-lib and that sort of compression algorithms. So these are easy to recognize. on the basis of analysis, and these are decompressed into native code, and there's a simple zip driving the emulator, and it knows that there's a 5-line assembly code which must be executed in the emulator, and AP-lib stream will have to be decompressed and then hand back to the emulator, and then hand back control, so that decompression can become a lot faster. If none of these should work, then there's the simple manual approach, which I will present. You take a hex editor, a debugger, and go step by step, and go through the outer layer and reach the original code. So how do we approach this from an antivirus standpoint? First of all, in the very first point, and few people know about this, especially those not involved in the antivirus business on a daily basis, we can safely say that every day 6 to 8 gigabytes worth of different malware is generated. And this seems a lot, but it's true. Over several years, malware producers have been using polymorphism and variants. First of all, they take a polymorph packer. If they do it twice, then MD5 will be different, a different key, different instructions on the packer side. But they won't stop here, because they usually add another layer, an automated mechanism, which on the server side will every 5 minutes do the polymorphism again. So every 10 minutes they can change the original code and shift the lobs, and the code will stay the same, but its appearance will change, and new linears will follow, and polymorph packing will be added. So on an hourly or daily basis, the process sequences can be changed, and the outcome will be quite different. And working backwards, thousands of various patterns can be generated on a website. Every 5 minutes a new binary code sequence can appear, and it can be contagious and infect the computer. It just depends on the update frequency, and URLs can't so easily be made to disappear. And as for ISPs, it will be a much bigger problem to fight these off and remove the malware detected URLs. Secondly, what can we do about this? The previous suggestion is one of the options, a Windows 32 emulator that is so good that would pass over 80 to 90% of the packers, and if we produce a virtual environment that is very well emulated, then it will bring us to very effective instructions. And that's one option. The other one is also very effective. It's to blacklist them. Because if you recall the previous slides, I mentioned that the black category is the easiest to manage for us, because if the black encryption is the category given, then based on the sequence, the packer can be recognized, and we can rely on this, because we can be sure that when we encounter such a packer, the probability is less than 0.1%. So if such a packer occurs, then it's very unlikely that it should be clean. They're used for malware. And the other thing is that we try to keep track of the license. And again, this ties back to the categories before. I mentioned that the most problematic packers belong in the white category, because they're the commercial protections that are the most difficult to handle from a technology point of view. And 90% of these are running on clean applications, generic .emida emulations, if I recognize all of them. And 60% of my clients will send me trouble tickets saying that they have clean programs that they bought licenses for and they don't want us to detect them as viruses. So then what we do is profit from the EM detection and defense systems that they include. Internal protection for the licenses and license keys, and there is license information included, so all the products that are protected will have the license information including the company. And that's useful because every now and then there are cracked versions on the web, and of course people who want to write malware will find those, and after that we can't clearly say that they are clean because sometimes there's malware included. But if we check the license that's included, then the terminal version license can be the basis for us to say that that becomes the black category because it's cracked or illegally released. And the IEEE project, which is a related subject, is taking shape right now. And let me just mention as a comment that for a time it was a problem that we as an antivirus company wanted to communicate with and approach various white category protector authors because their primary standpoint was that they wanted protection for their technology, and they had little understanding that we didn't want to actually burst through their code and bust their protection. We just wanted to identify them and make sure that they were not infected with malware. And of course, if we had some cooperation, we could do so more easily, but for quite some time they would not give us any information, and they saw this as benefit for us. First of all, if we could get information whether the program was infected or not, because this wasn't their vested interest, they thought. But recently we've managed to establish contacts with many of them, and in 6 to 12 months this is likely to yield results, which will mean that antivirus companies will be given a common interface for most of these protectors, and using the interface, the license can be queried so that they won't have discrepancy in their implementation of licenses. There will be a watermark level encryption of licenses in the given exe. The license information will be embedded in the middle of certain blocks. So if we find out that the license was illegally released, we can send them back the license, and they will know who to tell, who to watch. Maybe look inside the company for people who illegally released. The exe is running in a virtual environment because the supposition is that a virtual environment means that we want emulation for some reason, and lots of automatic emulation systems are out there which are based on QEMU and other V32 emulators are used, such as with VMware. It is possible to know that the video card can be queried, whether it includes the 3-trio string. And we don't even need difficult tricks. It's quite simple to do. And the antivirus emulator is different from the native machine in that it doesn't include the full kernel 32 that is with Windows XP, for instance. It's very easy to check fixed bytes in a different approach than when you gather information for exploits. You check a certain service back, and even in the case of many instances of Windows XP, and they will check the SEH entry point, and they will look for additional C3. Every normal kernel 32 will include that, and you can set a threshold as to the size in bytes. And normally an antivirus emulator would not load the full Windows 32 emulator kernel, and they will not find the relevant bytes, and what they will do is abort the program. They will just exit. And as I mentioned, lots of freeware application makers want some kind of protection for their technology, but they're giving away their software, so they don't want to spend money on this. So they will use a free packer, but most of the time these packers come from the gray area, and they're on malware, and they're added to normal programs, and we must be ready for that and use heuristics and other detection methods to avoid false detections for EXEs, whereas they're actually clean. It's even a bigger problem that malware writers found out. There was natural evolution a few years ago. First of all, they like to use publicly available packers and internet available packers, and then we can also recognize them and collect them. So first they went in the following direction. Open source codes were modified to a minimum extent, and then there were small variations. They reached a point where the source code no longer needed to be modified. They could write their own applications, and to this day this is the most current practice. There are malware families that use the same custom packer, and there are people who maintain this. And they're not clearly mounted on the internet, the World Wide Web. Everything has a price. In China we can send someone to crack a mailbox, and there's a price for a Gmail or a Chinese mailbox, and EXE packers can also be cracked and turned into a custom packer, and then we could get support in exchange for cracking it. And then we would let our customers know that we want X more weeks of support because a virus was detected, and then the virus is changed, and then again there is an extension of deadline, and our spam and malware can be propagated without restrictions. So we've gone this far, and it's making our life difficult because we don't have the source and we can't generate examples using simple programs. All we have is the perpetrated malware, and we can only check the consequences of their operations, and they are members of several malware families, and malware has its own evolution, changing on a daily or weekly basis, and the packers are changing, and technology is improving all the time. And a benefit for us, which goes back into the world of protectors. After a while, developers understood that we don't need Windows 32 fully operational EXE. So all the import and export tables, all the instructions workable, even runnable, that's not our objective. Our goal is to reach a level where we can penetrate this layer and analyze the binary code, and that requires at least one import table so that we can upload it and disassemble it. If we see what functions are called, we are lucky, but we need to find certain strings to hint that this is malware, and even that much may not be necessary in that case. A bit of statistics about what this looks like, and this is a quarterly internal collection we had. You can see the custom packers. They belong specifically to one or more malware families. And on the right hand side you see the packers that somebody procured and propagates over the internet. And of the top 3, you can easily see that the sample was in the range of 1 or 2 million based on a quarterly selection. And if you consider that writing one well-written heuristic detection, and we find UPAC 400,000 malware, that's very efficient. Otherwise, malware should be recognized one by one. Based on UPAC, I'd like to add that there are certain localization-based benefits. UPAC is a very small packer, a simple encryption program developed by a Chinese developer. It has a few tricks, almost like an anti-bugger, but it is a very efficient compression program, and it's widespread in China. A lot of people use UPAC. So false positive alerts have a lot to do with this, because we are not so keen on recognizing these, but it's not important in Europe, it's important in China. In China, it would be a mistake to blacklist it, but in Europe it isn't, because 99% of detections include malware. And you can see nicely here that with one detection, lots of representative patterns and samples from a family can be identified. And also in tips, the GEMPAC 132 in the third line, that means the 132nd generic recognition of the packer. So we must keep up with the developers. Now, almost closing the presentation, we can question the importance of the full packer category, whether we need this or not. It's clearly turned out that we don't necessarily welcome them, and we may not want to see them necessarily, because lots of people don't know that they're on their machine, and many people have come across them. Most people have actually, because they are there transparently. But if we lean toward the malware family, and we don't so much want to see them on our machine. And of course, what they want, I mean protections and protectors, what we want is to provide better protection for the applications that we want to defend. So we cannot do anything about this, because it's the generators, the developers' objective, and we'd like to have, from the old days, the IEEE project. So it would be a very nice idea to give us a uniform interface so that we can decide whether they're infected or not. Third-party issues are very important as well, because many people who release a free application will not spend on packers. Like in torrent, for instance, a few hundred kilobytes is the size of the application based on compression. So these will be around. Malware certainly won't disappear, not in the near future nor in the distant future. So custom packers will continue to be applied, certainly, and this is a very well-developed business, because they can generate cash out of this, and they can dynamically include their own ideas, rather than if they had to wait for a commercial product and wait until technology is updated, and then somebody should mount on the web their licensed copy. So what they do is they frequently update their own code. And there is a funny category that's recently emerged. Flash drives, very frequent, 7, 8 gigabytes worth. I think everyone in the room has at least 2. And with these portable applications sprang into being, these are following the purpose of installing an application which is a portable, and you copy one exe on your memory key, and it's like a fully functional installed application, because if you are using somebody else's computer, you don't have to mess with the registry or infect the machine. It's very sophisticated.
Vásárolta őket.
Now it's running under the name VMware ThinUp. So actually we have a mini virtual file system, a mini virtual registry, and most of the events to take place in the memory. Should we get out any component from memory, if we want to have access, then we should get something out of memory. We start the machine from flash drive and everything is packed in memory, and that's it. And before the demo, I may take a look into the future.
Ezt egy részből szintén megbeszéltük.
The white category is here to stay. In addition to the technology, they will change the packing algorithm. Because they would like to produce as little binary space as possible. So there is a competition how they can really pack the library, how they can optimize the library, and how they can optimize the code to have the smallest one. There's quite a number of firms dealt with it. We can't do too much with malware families. Yet more tricks to avoid detection is expectable, and they move forward at a good pace, and from time to time they pull very good tricks out of their bootleg. They make it more difficult to recognize them in binary form. It will stay. As far as defense is concerned, protection is concerned, then the present machine is much faster. 10 years ago, these defenses on virtual machines would use up lots of processor time because the procedures were magnified, and then if there is a small native code, then many tens of thousands of CPU cycles must be really evoked. It doesn't mean any problem when we start to initialize the machines, but with the increase of the speed and performance of the machines, such as flash drives and other hardware devices, the price go down. We may go back to the hardware key period. If it's cheap to produce any hardware, flash drives up to 1-2 gigabyte, and lots of things can be on it. It is encrypted, it is packed. Most of the code can be loaded on it and cannot be retrieved because it's not on the native machine. People who try to modify these codes and would like to mine these codes will have a difficult job to do. How many more minutes do I have? Anybody here? 2 to 3 minutes. Let me just show you two demos at the same time. It's going to be so interactive that you will get dizzy.
Egy részben a két végletből mutatnék egy-egy példát. Egy tesztapplikáció.
One extreme is about text application, compact. Show in a compact way in the header. There is a pack string. It doesn't say anything in itself, but from the bytes you can see that as far as entropy is concerned, it's a high level of entropy. This is packed, this is binary. And we may take a look at it, and entry point will show itself. This unpacking takes about this much time, and this is what I'm going to demonstrate now.
Ha normál esetben elvégben van állítva a breakpointom, az első kódeszük annyi, egy sima tömörítő, egyetlen egy trükköt.
If I have a breakpoint here, it's a packer. It uses an exception handler at the beginning, sets it, gives control to it, which gives back control to this code, and at the very end there is a jump instruction. It works, it processes all import-export tables and goes back to the original code. This was test application. Can be memory dump can be prepared, the sample can be analyzed, and then we can reset import tables in a dumped form, hexadecimal, and so on and so forth. Headers are here because they are part of memory, but the stuff that was here is encrypted and it runs. I could show you. I have 1 minute to show you the scanner, the use of the scanner, internal scanner. These are the categories that are actually recommended for an antivirus firm to write for native programs. And if it runs, then there is an exported decompacted object here, one exported object, and it is unpacked. With native code, without emulation, knowing decompacting, encryption, and so on, all the processes. That was the first example. Here I stopped debugging it. The second example will be, two parts will be shown to you. I dumped it before, so it's not totally interactive, not properly interactive. It belongs to the same family.
Minta, itt entry point.
Two samples, entry points. The code is of a different kind. It is packed. There are some deceiving strings. Ashpak is somewhere in the header characteristics. It is just a deception for the generator. There is, it has nothing to do with aspect. That's what it called this section. A simple trick is shown here. This is a DLL. The first lines utilize the initialization of certain registers on the native computer, subtracts two registers from another couple of bit tests, and if this condition is not met, then the next instruction generates an exception and it will jump out of the sample, nothing will happen. If it's good, then initialization will take place, which shows that fully antivirus engine must fully emulate Windows 32 loader with all special functions which Windows does when loads in an exe. Registers are initialized, exception handler built up with such a simple trick to defend it, and then two layers. This part is packed, but independent of this, where it has it gone. This is one layer unpacked. It would take long to debug because there are 10 to 20 loops with several thousand of instructions. It is still packed, but when a full emulation is done, then it is an interpretable code. And as I said before, import tables are not restored, but on the basis of strings, you can see browser names, HTML communication strings, and if we go down, then antivirus names can be identified. Bruce will autograph his book for 2 more minutes, and 2 more minutes, and then Bruce waits for you, for those who wants to have his autograph on his book.
Don't
have to analyze it any further. It will execute malignant thing and this will be the demo. Whoever has questions, stay here. Who wants to run to Bruce to autograph his book should run. Otherwise, I'm open to discussion. Thank you.
Én is köszönöm szépen.
There are some books in front of the staircase if you would like to pick them up.